In this video, we will find the quotient of two rational functions. So we are asked to find a function r of x, which is defined by the quotient of f of x and g of x. So what we have to do is we have to follow our steps that we earlier learned for how to divide rational expressions. All right, so the first thing we're going to do is follow step 1, which tells us to rewrite the division problem by multiplying the first expression by the reciprocal of the second expression. All right, so I'm going to write it out as a division problem. So r of x is going to equal the quotient of f of x and g of x. So r of x equals 2x squared over x squared minus 8x, because that's the f of x function. But then that is going to be divided by the g of x function, which is 8x squared plus 24x over x squared plus x minus 6. So I haven't written it as the product of the first expression times the reciprocal of the second expression yet. I wrote it as a complex fraction right now. I know this is a complex fraction because I have one main fraction bar. That's the fraction bar I drew in blue. And the numerator is its own fraction and the denominator is its own fraction. Now this main fraction bar, that means division. So when I rewrite this problem, I'm going to rewrite it as the first rational expression times the reciprocal of the second rational expression, because really what I'm doing here is one fraction divided by another fraction. So my r of x function is 2x squared over x squared minus 8x times, and now I'm going to do the reciprocal of the g of x function. So x squared plus x minus 6 over 8x squared plus 24x. That brings me to step 2. Now I'm going to factor everything in the numerator and the denominator from both functions. So r of x is going to equal 2x squared in the numerator, because there's nothing to factor, that's just a monomial. But in the denominator I have a GCF of x, so it factors to x times x minus 8. Now in the second fraction, the numerator is the trinomial x squared plus x minus 6, and that factors to x plus 3, x minus 2. And in the denominator I have a GCF of 8x, so we get 8x times x plus 3. Now, in step 3, it says we're going to multiply the numerators and the denominators. So really all I'm going to do right now is I'm going to combine them into one fraction, because when you multiply fractions, you just multiply straight across. But as I do it, I'm going to factor even a little bit more. You'll see what I mean as I get to the next step. So my r of x equals 2x squared, but instead of writing x squared, I'm going to factor it as x times x. And trust me, when I start dividing out common factors, you'll see why I did that. And then it's going to be times x plus 3 times x minus 2. And now I only have one fraction bar because I've multiplied the two fractions together. So in the denominator, I have x times x minus 8. Now I'm going to multiply that by 8x, but I'm going to factor 8 into 2 and 4. And again, you'll see why as soon as I start dividing out common factors. And then that gets multiplied by x times x plus 3. So now I have one fraction. Anything I see in the numerator, if it has a common factor in the denominator, I can divide that out. So you'll see I have a 2 divided by a 2. So that's why I rewrote the 8 as 2 times 4. So you would see that you could simplify 2 divided by 2. Now, I used to have an x squared in the numerator. Well, I've rewritten it as x times x. So you can see that both of the x's in the denominator will also divide out. So for every 1x in the numerator, I can divide out 1x in the denominator. The binomial x plus 3 is also common, so I can divide out the binomial x plus 3. So in my numerator, I have the binomial x minus 2 remaining, and in the denominator, I have x minus 8 and 4. So now I'm ready to put my final answer over here in the box on the left-hand side of the screen. So for my final answer, r of x equals the x minus 2 in the numerator over 4 times x minus 8 in the denominator, because those were the two leftover factors in the denominator, and I just put the 4 in front. You could even distribute the 4 if you want, and if you want to make your denominator 4x minus 32, that's fine, but there's no need to do so. You can leave it just like this. I hope this helped you learn how to divide rational functions.